This next section, we'll be using our formula to solve word problems. And in this kind of questions, we usually need to apply trigo concepts because we'll be dealing with a lot of triangles. So the first concept to know is that the numbers, or rather the given lengths in the questions, are usually the hypotenuse of the triangle. And now the second concept to know is to know how to use 90 minus theta. Now there's a trigo identity we need to recall, that sine 90 minus theta equals to cosine theta, and cosine 90 minus theta equals to sine theta. This trigo identity will be very widely used, as you'll see in the examples later. Now for case 1, how do we get the 90 minus theta in a triangle? So let's say the question was given to you this right angle and this theta, and we need to find this angle. How do we do it? Of course, it will be 180 degrees, which is the sum of angles in a triangle, minus your 90 degrees and minus your theta, which gives you 90 degrees minus theta. And for case 2, in a right angle. Now right angle, as everyone knows, is 90 degrees. And the question gives you this theta and wants you to find this angle. So obviously this angle will be 90 degrees minus theta. Okay, so let's see how these concepts are applied in the following example. The diagram shows the cross-section of a house with a rooftop BAC. The length of AB and AC are 10 meters. 10 meters is here, and AC is 24 meters here. The angle between AB and the horizontal through A is theta, which is right here, and angle BAC equals to 90 degrees. So this right angle here. The base of the house is of length L meter. Part 1, show that L equals to this equation. Now you'll see that in the equation there is cosine and sine. So it shows us that we'll be applying our trigo knowledge and we'll be dealing with a lot of triangles. Now it's not really possible to find L directly, being the base of the house, like using this line right here. But we can note that L is also equals to this horizontal over here, which it is the sum of XA and NAY. You'll see that XA is one of the lengths of this triangle, while AY is one of the lengths of this triangle. Therefore, using trigo, we can find the lengths of XA and AY separately and add them together to find the length of L. Now we have identified the two triangles that we'll be focusing on. Now bring back to concept 1. The numbers in the questions are usually the hypotenuse of the triangle. So for triangle XAB, 10 meters is the hypotenuse, and XA is the adjacent, and XB is the opposite. We have our hypotenuse and we want to find XA, which is our adjacent. So using Tuakaso, we will know to use cosine. Cosine theta will therefore be equals to adjacent over hypotenuse, XA over our hypotenuse 10. And then we want to make XA the subject. So XA equals to 10 cosine theta using cross multiplication. Now we have the first part of our equation. Moving on to finding AY. This is where we have to apply concept 2, knowing how to use 90 minus theta. XAY is clearly a straight line, and the angles on a straight line add up to 180. We have theta and a right angle within that straight line. So in order to find this angle, it will just be 180 minus 90 minus theta, which is equals to 90 minus theta. So we know that YAC is equals to 90 degrees minus theta. And we also know that 24 is the hypotenuse, and then AY will be the adjacent, and YC will be the opposite. However, remember that the angle is cosine 90 minus theta. equals to adjacent over hypotenuse. So AY over 24. From our trigo identities, we know that cosine 90 minus theta is also equals to sine theta. Therefore, we'll let sine theta equals to AY over 24. And then using cross multiplication, making AY the subject, AY equals to 24 sine theta. L equals to XA plus AY, which is equals to 10 cosine theta plus 24 sine theta. And that's how we arrive at this equation. Now part 2. Express L in the form r sine theta plus alpha, where r is more than 0 and alpha is an acute angle. Now this is where we use our knowledge from our formula. Since the question has specified the formula they want us to use, r sine theta plus alpha, then we need to rearrange our L expression so that sine theta is in front. So instead of 10 cosine theta plus 24 sine theta, we'll rearrange it to 24 sine theta plus 10 cosine theta. Following the steps, we'll identify 24 as our A and 10 as our B. And the formula to derive the value of r is holding square root a square plus b square. So plugging in, we'll get r equals to 26. And for our basic angle, the formula is tangent inverse b over a, so 10 over 24. And that's how we get 22.620 degrees. And then we'll round this up to 1 dp, so 22.6 degrees. And then subbing it all in into our r formula, we'll finally get 26 sine theta plus 22.6 degrees. Part 3. Find the longest possible base of the house and the corresponding value of theta. So if you recall, base of the house just refers to L. Now whenever you see the word longest or any form of superlative, we know that we are finding the maximum value or minimum value. In this case, since it's longest, we are finding the maximum value. We know that our minimum value of sine is -1 and our maximum value of sine is 1 from our sine graph. Then we will build on to it to form our original L expression, which means we'll multiply it by 26, and therefore multiplying the minimum value by 26 and also the maximum value by 26. That's how you get the range of -26 to 26. Therefore, we can infer that our maximum longest base will be 26 meters because this is our new maximum value. Now we need to find the corresponding value of theta. We can let sine theta plus 22.6 degrees equals to 1. Because in our original sine graph, without the 26 in front, the maximum value is 1. Or if you cannot visualize it, you can take 22 sine theta plus 22.6 equals to 26 first, because we know that 26 is our maximum value. And then you will divide 26 on both sides, and you will still end up with sine theta plus 22.6 equals to 1. Afterwards, we can draw our sine graph, and we know that our maximum value is 1. And when does it occur? It occurs at 90 degrees. Therefore, we'll know that theta plus 22.6 degrees equals to 90 degrees. And we can find theta, 90 degrees minus 22.6 degrees equals to 67.4 degrees. Now moving on to the next example. The figure shows two triangles OAB and OBC. It's given that OB equals to 4 meters, BC equals to 1 meter, angle OAB equals to angle OBC equals to angle OXC. Now, please note that there's a missing x and the x is actually down here. So OXC equals to 90 degrees. And angle OAB or AOB, equals to theta, where theta varies. So part 1, show that OX equals to 4 cosine theta minus sine theta. We can infer from our diagram that OX can also be equals to AO minus AX. Now comparing with the given equation in part 1, we can kind of infer that 4 cosine theta equals to AO and sine theta equals to AX. So now we just need to show how we get to this point. So you can see the triangle that we need to use to find AO is quite clear. Is this triangle over here. Because we have our theta within this triangle, and then we have a given number of 4 meters. However, in order to find AX, it might be a little more tricky to see. So if you look at the positioning of AX, it doesn't seem to be within any sort of triangle. But if we draw a line here, we can actually form our own triangle. Now let's say we mark this point as D. And this will be our new right angled triangle that we formed. We can see that AX is also equals to BD. And BDC is a right angled triangle with a given number or given length of 1 meters at BC. Now the next step is to identify where is the theta in this triangle BCD. Have to use our 90 minus theta because from our geometrical properties, we can see that this angle BOA is equivalent to this angle DBO because of the property of alternate angles are equal and BD is parallel to AO. Therefore, you will know that DBO is theta, and now you can find CBD, which is 90 degrees minus theta. So now that we have all our angles labeled, we can start solving for AO and AX. Now we'll start with AO first. We have 4 as our hypotenuse and AO as our adjacent and AB as our opposite. So using Picasso, we know that we'll be using cosine. Cosine theta will be equals to adjacent over hypotenuse. So AO over 4. And then making AO the subject, it will be 4 cosine theta. Afterwards, we'll deal with AX. So now looking back to our triangle BCD, we can identify 1 meter as our hypotenuse, BD as our adjacent, and CD as our opposite. Since we need to find BD, we're using cosine again. So cosine 90 minus theta equals to BD over 1. And we know that cosine 90 minus theta equals to sine theta. So sine theta equals to BD. And since BD equals to AX will be equals to sine theta. And now, putting everything back into this equation, OX will be equals to 4 cosine theta minus sine theta. And therefore, we have shown our answer in part 1. Now part 2. Given that OX equals to r cosine theta plus alpha, find the positive value of r and the acute angle of alpha. So unlike the previous question, since our cosine already came first in our expression for OX, we don't have to rearrange the equation anymore. Now following the steps, we can identify 4 as our A and invisible 1 as our B. And then plugging into our R value formula, we'll get square root 17. Since we always need our R value to be in exact form, we'll leave it in the square root form. And to find our basic angle, tangent inverse B over A, we'll get 14 degrees, round up to 1 dp. Then plugging in, we'll get this expression for OX. Now part 3. Find the value of theta when OX equals to 3.2 meters. Firstly, we'll let our OX expression in the R formula form equate to 3.2. Then we'll shift the root 17 over by dividing it on both sides, and then you'll get cosine theta plus 14 equals to 3.2 over root 17. And then adding one more step here, theta plus 14 degrees will be equals to cosine inverse 3.2 over root 17, which is equals to 39.094 degrees. Then finding theta, 39.094 degrees minus 14 degrees equals to 25.094 degrees. Rounding up, 25.1 degrees to 1 dp. That's how we get our part 3 answer.